My pleasure today to introduce our presenters, Chris Olsen. Chris is a consultant, author, trainer in Cisco. He covers such technical portfolios as networking, security, data center, collaboration. Chris is also a CCSI. He's a certified Cisco systems instructor. And I just want to say that he has just recently been awarded the Cisco Distinguished Instructor Award for 2021. Congrats on that award, Chris, and it's all yours. Let's begin.
Great, thank you, Brad. Appreciate the compliment as well. Welcome all to the webinar here. Also, as Brad noticed, at any time, if you want to ask questions in chat, feel free to enter them any time. I'll have them available on a separate screen. Just take in mind, depending on the quantity and the rate they come in, I might dovetail and answer some of them during the presentation. And if you don't mind, I might put some of them off towards the end, exactly as Brad stated. Okay, so this topic is about Cisco ISE and security in a campus network. So the topic here would be any place where any user can connect to a data network, which brings a good question here, and that is, what is the best place to put network security? Let me first comment how it used to be when I got started in the networking world back in the 1990s. Somewhere off here, there would be a connection that went off to some various internet-facing devices, and we'd connect off to the grand internet over here. Of course, on the internet, we'd have some firewalls that were internet-facing. Okay, that, of course, has been this way for decades. No one's making any statement that shouldn't be that way. But what about if a user sits down over here with an iPad, an iPhone? What if they come over here in a wireless connection on their laptop? What if they connect in with their physical machine? Question, what role does that firewall over here play for all those users connecting in, which is now potentially in so many places throughout the network? So while we're good on connection from outside in, what about all those that are in the physical structures of our network and are connecting inside there? So what's a good place to put network security? The new answer is everywhere, but most specifically, as close to the source as possible. Whenever a user first connects in, that's the best place to check everything with security. Otherwise, couldn't they potentially connect in, start going through the network, and then, oh, finally another firewall over here blocks them for unauthorized traffic. Meanwhile, any authorized or unauthorized type of traffic has been allowed to go through the network here. Point is, to that degree, we're less secure. So Cisco's main approach, campus-wide, is our topic here for this presentation, and that is the Identity Service Engine, Cisco ISE. ISE uniquely is a Cisco product, and this product does many different things regarding the same issues on security. So to state that it just does a few things would be an extreme understatement. Side note, there was a prior product Cisco had called Cisco AnyConnect. That product dated back from the 1990s, but as of a few years ago, Cisco has gone end of life with that. ISE has been a full replacement of AnyConnect, as well as a superset to that. So Cisco ISE is a server, or perhaps more than one server. The server of ISE, two options for installing. One, it can be downloaded from Cisco's website as an OVA file. That means you install it as a virtual machine running on VMware. If you wanted to try in your lab environment, you don't have to buy any hardware initially. ISE could be downloaded and just run on any server running perhaps VMware ESXi. Option two, for a larger scaling in production, ISE runs typically on a dedicated server. This dedicated server has been customized for Cisco uniquely for ISE itself. So if we start out small, there would be one ISE server. Then that ISE server, as represented over here, would then have the ability to connect to the different devices where we connect in. And these devices are called NAD, Network Access Device. This is a general term, which means the first device users connect into when they access the network. Notice the concept here is they're already in the building, they're in the structure, they're in our lobby, they're in a cubicle, they're in our cafeteria, whatever it might be. They're in the physical structures or right outside of it if the wireless is connecting that far. So the idea is the first device they'll connect to is the network access device. This could be a physical switch, a wireless access point. This could also be a place where a VPN terminates. So ISE will talk to all of these with a protocol called Radius, Remote Access Dial-In User Service. Radius is a protocol that goes between ISE and the NAD. Now, we had another webinar a month ago, and this was where that topic focused on. We're going to take the next steps here to add security to a much higher level. But just to finish the flow of connecting in, so here I'm connecting on any type of device. This could be a laptop, maybe it's an iPhone, maybe it's an iPad, maybe it's Internet of Things. That's another huge trend in our world today, where technologies, computing devices of a wide variety have the ability to connect on the internet. They're Internet of Things. In a hospital, this could be a medical device. It could be a device where a doctor takes notes. It could be in manufacturing. It could be in electric power production. These are any device that in any way traditionally weren't IP-based, but the trend in the past many years is make them IP-based to leverage the existing network. Point is, that's more things connecting in here. So this protocol is 802.1x that works with Radius. So the NAD talks Radius to ISE, Internet of Things, and all our devices connect in. That talks 802.1x over here. 802.1x is the first line of defense to gather username, password. Send it to the NAD. The NAD talks to ISE, and the ISE either has those usernames and passwords inside, or perhaps can talk to Active Directory or an LDAP server or a third-party database to access the user data store, often called the identity store, where the users and passwords are kept. So again, the users and passwords could be kept on the NADs. That wouldn't scale very well, because if we had 500 NADs and we have 2,000 users, then all 2,000 users would have to be typed in, every NAD, repeat over and over again. Terrible solution. Better approach, centralize over here with ISE. Next is, how many devices can we connect in, even on a daily basis? Recently, I've been working with a customer, and they have 1 million total devices that they're connecting in through their various NADs. It's a large healthcare environment over many different geographic locations, all centralized with various ISE. Conclusion, one ISE server, not going to cut it. Not enough load balancing, no fault tolerance. And again, what about all the CPU and RAM load on it? Therefore, an intelligent architecture of ISE would be to set up different roles or persona. Role and persona means the same thing. When ISE is installed, the 4 current personas that can be chosen is, one, what you and I would do for administration. We would sit over here at Windows or Linux, and we connect into the policy administration node. That's the web portal where you and I configure everything, change a setting, add all the features like those you'll see connecting through the webinar. All right, so what if a user connects in and they're in our network? Let's say here's the rest of the network and they have access. And we want to know 2 months ago what happened. So in ISE, there is a logging feature called monitoring and troubleshooting. This means a big giant log server. Well, this role could be, we could spread these out. This could be one server, that's another one. Or they could be the same. Or they could be a different virtual machine, or a different hardware appliance, depending on how high we want to scale. Next is, when Radius connects in, it's going to talk to the policy service node. So for that environment I was mentioning with 1 million simultaneous users, or throughout a day, they have architected to about 25 different policy service nodes strategically located in different geographic locations, all centrally operated under one ISE environment. So this scale is very, very big. It's not designed just for a few people. It's designed for the largest of large. Other option, what if we have other third-party security tools? And these security tools, whatever they are, we want to implement and take advantage of what ISE already knows of the connection in. So what Cisco's created is an API application programming interface known as PX Grid, or Platform Exchange Grid. This is an API that Cisco has helped create and standardize to allow other third-party security products that support the API to coordinate and work with ISE. So a user connects in, we know about them, why not share the information with other products to further expand and add upon the security? Okay, our focus here will be, well, what's built into ISE that we can do to significantly add to the username and password level of security? So a big trend that has happened in the many years is the idea of BYOD. A little side note, where'd this come from? Well, if you've been to a bar or a restaurant or perhaps a private party in the last several decades, you may have heard the expression, bring your own beer, BYOB. Well, the IT industry decided about 15 years ago or so, let's change that fun little social acronym to bring your own device. A little play on words with bring your own beer, bring your own Hawaiian punch, whatever the term may be, but here it's bring your own device. So now what that means is any user, a guest, an employee, a contractor, or consultant, what if they go to the Apple store, buy an iPhone, buy an iPad on their own? What if they go and they buy their own laptop? They want their own tablet. They prefer Google's products. They want an Android. Maybe they have a unique type of phone, all of which have wireless or Ethernet wired. That's the idea of bring your own device. It means a computing device of any type that is not authorized by the information technology department in any organization. Users said, I like this, it's cool. I use it for home, why can't I take it to work? I have my tablet at home, why can't I take it to work and check my email and do other productive things? Again, 20 or 30 years ago, the quantity of devices in a campus network for users, there wasn't much to choose from, like the computer or an Apple laptop or an Apple computer. But today's world, the diversity of offerings is quite great, which brings the point. If they log in with the right username and password, does that complete all the aspects of security for that device? We know the right username, we know the right password. Well, what if that device has a virus? What if that device has a malware software on it? What if that device has any kind of malicious software? What if that device has any software that has the ability to connect to the network? And now we let them in the production network. So even though 802.1x securely required that username and password, they just took that tablet in the cafeteria, in our break room, in any place in the environment, and they could potentially bring in any type of malicious software. That's the nature of bring your own device. What's the limitation of what they could bring in? Well, if they have a wireless access on their computing device, and we give them a username and password for a guest access or limited access, still we gave them access. So the point is, how do we take that further and lock it down? So ISE has several examples of what we can do to provide added security for any type of device that connects in. Again, this could be bring your own device provided by a vendor for a certain project we're on, provided by a department that might be needed, but we have some third-party options of computers, tablets of any kind. Whatever they are, if they're in the network, they could potentially cause a security issue. Again, back in that firewall that connects us internet facing, that's not going to do a thing to be able to address the fact that someone is sitting in our cafeteria or in a cubicle and they walked in, and any malicious software they have could potentially now affect what's inside the network. So the idea is, how do you add security to something if you don't know what it is? Like, I want to apply security to something, but I have no idea what that thing is. How do you do that? Just a rhetorical question. Pretty hard to do now, isn't it? ISE solves that. So ISE is all involved with all the factors that affect when we connect in. Example, first we start off with a who. Well, username and password. That got authenticated. We know that's valid because we can enter that in ISE. We allow that. All right, what did they connect in with? Was that an iPad or a Windows 10 laptop? If you ever studied and monitored the flow of viruses and the ability to contaminate a Windows 10 device versus an iPad or iPhone, it's not the same attack vectors. Hackers look at unique things that are unique to the operating system. So what we would do to lock down an iPhone, it's not going to be the same as a Windows 10 laptop, nor should it be. Different operating system, different files, different method of arranging files in the disk. Point is, bring your own device. How do we know what's out there? So ISE is very much involved with, well, what is it? How did they connect in? This could be wired, wireless, or any kind of VPN connection. When did they connect in? So ISE does default logging. So anytime anyone's connecting in, the when, like the date, hour, time, is fully monitored. So for later for logging and analyzing any security breaches. Where did they connect in? Well, this could be like wireless access point in building 12, floor 3, East End, Seattle, Washington, whatever it might be. And with that, again, what are the possible threats that any device could bring in? Any malicious software that's ever existed, that exists on a computer, wait a second, didn't they just walk in the network with us, with that? And therefore, ISE takes it to a next step and then says we could allow certain degrees of guests to come in. So this example here would be not for an employee, but how ISE could allow different guests to come in. If you've ever played basketball, a favorite term I like to use here, nothing but net. In basketball, that means you made such a good shot, it went right through the hoop, didn't even hit the rim of the backboard, nothing but net. Well, ISE, we could playfully use that same term. If we connect into a hotspot, we could give them internet access, but nothing but else. In other words, nothing but net. So they're sitting in our office and we give them guest access. They can connect in, but we just ship them right out the door off to the internet so they can check their personal email on the internet, whatever it may be. As an instructor, when I travel to many other locations, I've been to some very secure locations, and this is an easy way to provide access if I have no, or the guest has no other need to access anything else. Okay, next example, we could take that a step further, and we could say, we're going to have a web portal. Well, ISE is a whole bunch of web servers built in. Web portals, there's a bunch of them, not just a few, and they're all built in the product. And they have different URLs, but you want to set up a web server for login, all right, that's ISE, it's already built in. So the idea here is I connect into that, and then I can self-register. This means I enter in who I am, what I'd like to do on the network, and then a sponsor is an employee in the organization dedicated to reviewing these and then approving or declining. Oh, we see that you're a registered guest for this week and Joe's connected in. Okay, I'll press the button. Joe, you're allowed to come in. What if we have a big event or there's something happen in our auditorium, we're giving a presentation to 500 guests. We want to give them wireless, want to make it easy. So we could get all those usernames ahead of time and give it to a sponsor, meaning someone in our organization. Doesn't have to be a very technical person, but they have to have a web browser, they connect off to ISE, and they can create hundreds or thousands of temporary usernames, passwords that they could give to the guests. So when the guest comes in, they now have access, they can connect inside the network. Point is, all these things, ISE knows about them. Once again, how do you provide security if you don't know what it is, you don't know what they're doing, you don't know where they're doing it? Pretty hard to do now, isn't it? Especially if someone's bringing in their own device by that. And once again, ISE is the center of all that, and provides the basis of where we could achieve those goals. Side note, another big trend in the world of Cisco that we're seeing over here is the idea that products can support and implement an application programming interface. If you're new to this term, API has been around for quite some time. It means, simple analogy, take a computer software program, take another software program. What if these two programs need to talk or communicate in any way, like share information, share login information, or content of a database or content of data, whatever. Software program A wants to talk to software program B, whatever A and B are, on the same computer over the network. Well, software programmers have solved that by creating an API. An API is a way to allow one program to work with another. API also allows for all kinds of programming, automation, and orchestration. Because if you can do a task once, what if I have to do it 100 times? Why couldn't I write a computer program, like in Python or a programming language, to do that? Well, the most common API in the world today is representational state transfer. Point is, ISE supports that common open standard. 21 years ago, a really smart guy named Roy Fielding noticed that, hey, a lot of people in the 90s, they take a web browser, go into a website, and a lot of people are doing that. Pretty valuable way of sharing information. Web browser to website. What can you do? Look at info, delete info, copy info, add up information, provided you have security access, of course. That's how REST was born. Instead of web browser to web server, it can now be any kind of programming to the REST API that ISE supports. Side note, Cisco is doing this with lots of other products. In fact, there's a whole new certification and training path just on the idea of APIs. It's called DevNet, right? There's the Cisco Certified DevNet Associate, DevNet Professional. That's all in how to use these APIs for any type of product. Not our focus here, but the fact that you're seeing it here, again, it's being exposed and made available by Cisco on many other products, like the whole rest of the world is doing. Okay, so now that we have a guest set up, well, what if the guest has a device and we've already authorized it and they're in our network? Or perhaps, what if an employee has a laptop and we've authorized it with ISE? Now, ISE can do quite a bit to add security to that device, provided they've logged in, like add a digital certificate to that device, verify that device is truly authentic, and associated with the user that logs in on. Well, what happens if the user's laptop or tablet or phone gets stolen or lost and they just can't get it back? A fair question would be, what if an unauthorized user, hacker or criminal, found the laptop, knew where they worked, walked into the cafeteria, sat down with the stolen laptop? If they had the username and password, somehow the user was careless enough to have that, well, potentially they now can impersonate the user and connect in. So, conclusion, if a user loses or gets stolen a device, they can blacklist it. So I lost my laptop on Monday. Look all over, man, I can't find this thing. But I want to keep things secure, so I'll be a responsible employee and go to a simple web portal built right into ISE. This is not on the cloud, it's literally on ISE in our network, the web server. I'll enter in my device, I'll submit it, and then I'll mention that it was stolen or lost. Later, if a criminal were to get a hold of it, and even if they got the username and password, granted, we should make it hard for them to get that. But what if they got it, they walk in our cafeteria? Well, if it's blacklist, they're going nowhere. So even if they've stolen the username and password, they can't get in. Even if they stole the device, still can't get in if it's blacklisted. Again, this is just one of the features in ISE to lock down those unauthorized users. Rob, can ISE do system profiling? What do you know? What a perfect question. Hey, that's the next slide here. You bet. Absolutely. Rob, your question there was in perfect sequence of time. So profiling is another feature of ISE. It is off by default. you check a few boxes to turn it on. Profiling means identify exactly what that device is. Again, how do you add security to a device you have no clue what it is? I have no clue about that thing, and I want to make it secure, but I don't know what it is. How do you do that? Solution is profiling. So when the user connects in, again, this could be a tablet, it could be a laptop, it could be an Apple product, a Google Chrome tablet, on and on we go. Whatever it is, ISE already has a very elaborate built-in profile of non-Cisco products, right? Cisco doesn't own Microsoft, Microsoft doesn't own Cisco, of course, but the database has the profiling of all that data built in. It's quite big. There's a lot of devices in there. Have you ever wondered how many devices as a consumer could I go buy if I like a different type of computer? It's a big list. And that list is found in the profiling database. In addition, clearly manufacturers and developers are constantly working to create new products. That's a good thing. Innovation in a free and open market gives a lot of nice benefits for consumers like you and I. Go to a store today, your favorite consumer store or online. How many computing devices can you buy? Man, it's a big list. Beautifully big. That's what this database already has in it. It's a detailed database of all the different types of products that can connect in. So when that device connects in, oh, there's an iPhone. We know about it. First step in security, know what it is. Can't provide security if I don't know what you are. So any other device like a tablet, medical devices, third-party devices, printers we should add here, physical phones, soft phones, another type of voice over IP phone as an added appliance, third-party ones, a third-party individual SIP phone. It's amazing how many there are that are already in that profiling database. And in addition, Cisco is very vigilant to learning the whole world of all new computing devices ever created and constantly updating that right into your ISE. That feed service, you just press a button, must have internet connection, of course, turn it on, meaning it's just literally a feature you enable, which will go on to Cisco's cloud database that's collect globally, and all the new devices that are added keep getting added on here. So let's say next week, some guy named Joe makes Joe's new tablet. I'm making this up, of course. Don't know who Joe is, but if he's got a tablet and one or more customers might buy the tablet, Cisco's going to find out about that in a good way. Not trying to harm Joe, but we want to know information about that. So when Joe's device connects in, we have it profiled. Again, profiling doesn't start till after logging in works. So we have to log in initially first. The original login has to take place first. So 802.1x always happens first. What if the username, the user connecting in from our laptop never had a valid password for ISE? Well, they're not getting in. So we don't profile that which isn't in the network because we don't have to secure that which doesn't need securing. It's not in the network at all. So logins must occur first, which brings another question. What if 802.1x, the most preferred, desirable, more secure method of authentication? Well, that protocol does need to be on the end node device. This is called a supplicant. Supplicant means software on a device that supports 802.1x. The word supplicant means to supplicate or to beg or ask for something. May I please have something? That's to supplicate. Well, in computers, that's a supplicant when it's software that says, may I log in with username and password? If that process doesn't work or it doesn't succeed, profiling does not begin because we don't identify a device that hasn't been connected in. Next scenario, what if we have a device that just will not support 802.1x? Example, a printer. Most printers don't have a mechanism where you can add software to it. So in Cisco, the software to add this is called AnyConnect. AnyConnect is really the essence of this. It is a free download, and notice it allows us to connect in any way: wired, wireless, VPN. That's the idea of AnyConnect. The software is free from Cisco, and if it's on these devices, then they are a Cisco 802.1x supplicant. In addition, that'll give us a lot more ability to provide more security to them. All right, but what if you can't put 802.1x there? An alternate to this is a much less secure approach called MAC authentication bypass. MAB is a way of saying, well, if you can't get high-level security, let's do something a little better than no security. And all this does is say, take the MAC address of the device, and you and I would simply enter statically, manually, the MAC address inside ISE itself. If you had 1,000 devices to do, that'd be 1,000 MAC addresses to enter. So a better goal is to use 802.1x. Better approach. If you want access to our secure network, you need this protocol 802.1x that will allow us to let you connect in securely. So what can you put AnyConnect on? Apple products, Microsoft products, Google products, Linux is the main category of them. Okay, printers, nope, not going to be able to get AnyConnect on that. Pressure gauge valve, pressure gauge for a valve in an industrial process, probably not going to be able to load AnyConnect on there. Okay, but they could be Internet of Things. So wherever there is AnyConnect, point is our ability to add security gets significantly higher for sure. Okay, so Rob's question further, can I take that further? If I don't have 802.1x, the option is MAC authentication bypass on Rob's question. Other option is web auth. And this is a better answer than MAB, but this is the complete answer now to Rob's good question there in chat. So the three methods are 802.1x, by far the most secure. Next best would be a web authentication. Third best would be MAC authentication bypass. The web authentication means a website in ISE where a user can connect in and authenticate to a web portal with a web browser. This is often done by their device being redirected to the web portal. Redirection of web can be used for hackers, but it's used constructively here to send them right to the ISE portal for login. So, Rob, on your question, next best answer is web auth. Excuse me, web auth means web authentication with a web portal in ISE. 802.1x best, web auth second best, MAB way down there is our third best, or none of the above. We could always do nothing and let our users or anyone connect right in. So if you take off all these, we have an easy network, but the least secure. Side note, as an analogy, easy and security are often opposites, I would argue. What would we do if we wanted the easiest way to access a network? The easiest way, well, don't do ISE, don't do 802.1x, allow a lot of wireless access points, don't ask for username and passwords. It sure is easy to connect, but terribly unsecure. The most easy is the least secure. But the goal is we don't want to make it highly problematic for users to connect in, but if they don't do anything, then security is the lowest. So we have to make them do something. So 802.1x the best, web auth second, and then MAB the third. Yep, see your comment there, Rob. Okay, yep, those are the three key options that ISE can work with. Another side note, again, more on 802.1x. What this means is it is a collection of protocols as an umbrella. For example, what if you have a key to your house You lose the key, somebody finds it, they go to the hardware store and they copy the key. You find your key again, but they got a copy. Time is bad for security. If we were to quickly change our lock, then we would stop that lost key and that reproduction of it. The longer you wait in anything, the more time a hacker could break into. What about a password or security? So if I have a password to anything, time is always the enemy. The longer you wait with the same password, the more time an unauthorized person could potentially find it and break in. Change your passwords often. It's annoying, it's pestering, but always more secure for sure, because time is less for this. Okay, Mike has a good question. When can your profile apply dynamic ACL or VLAN? That's an excellent point. So on that leads right into this discussion here. So if a user connects in, if they have the right username and password, if they are authenticated with 802.1x, then we can say, well, what are we going to let you do? Let's say over here is our data center that we would connect to off of a WAN link. Let's say over here is our other campus network. That's the sloppy word campus, but another connection somewhere through our network here. So what ISE can do is apply what's called the dynamic access control list. Literally, ISE is now a switch configuration editing tool all on its own. It can dynamically change the access list to say, oh, you connected in with an iPhone. All right, I'll let you out to the internet, but not our data center. Oh, you connected in with a laptop that has authorized software on it. Okay, so now you've been profiled. So now I'll change the access list. ISE does this automatically to give you access to our data center. So when the login occurs, 802.1x works with Radius. And Radius was designed in a good way to be a very flexible protocol to allow other features to be added to let further additions to occur of what we do security. Mike, thank you for mentioning. Next point, VLANs. If we connect in here on a layer 2 switch, when I connect in, what if ISE could go inside here and change the VLAN to allow you to only connect to the internet? Or based on your profile, now you connect to the data center because you'd be on a different VLAN that has different access. So ISE is an automatic network access device configuration tool built in. And the profile can act upon that. So with this, in any programming, we have all kinds of methods of logic. Like if you ever studied any programming language, a common logic in any programming, whether it's C, Java, or Python, is if, then, else. If this condition is true, then do that. ISE has all that built in. But you and I don't have to study Java or Python or another programming language. We can program ISE by drag and drop with a mouse. We can say if your profile was an iPhone, then you'll be on this VLAN that will get you to the internet. Sorry, nothing else. If your username and password is in our certain group that we have an active directory for our known approved contractors, then you've been profiled with a valid laptop, you can access our data center. So you can do a tremendous amount of different programming logic without doing anything in a programming language by just dragging and dropping logic in here. If this, then you can do that. If you profile here, then you can do that, and so on. Question here. Corey asks, why does ISE have to authenticate before it profiles? Well, the idea is if we're going to be secure on the device, the first step is to know that you have valid authentication. In better words, if you can't even log into our network, the logic would be, well, how much should we have the authority of restricting what you can do? Because right now the answer is nothing because you can't log in. So all logic is log in first. If you can't get that far, we're not going to do other things on top of that. And the next topic here, Corey, will show all the different things we can do or ask to the device. But I think that it's how ISE was built. And I think that logic is pretty sound. First, let's know you're authenticated before we put some rules on you. And to take that further, Corey, that our next point here is all about posturing. Posturing is the next step after profiling, which is otherwise known as compliance. So in the world of ISE, these are the same thing, posturing and compliance. Now, what is the definition of a laptop that complies? Answer, whatever you want it to be and how we configure it in ISE. So Cisco doesn't say what the definition of a secure laptop should be, or a good iPhone should be, or what app should you have on, but you and I can do that. We define that as we configure ISE. There are a huge number of options on this. Let's say as an example, the user can log in, they got the right username and password, but do they have a virus on the laptop? Logging in, we wouldn't know. We just know they got the right username and password. But what if they have a virus on it? So what we can do once we identify them with profiling, we know about that device, you and I could do programming logic in ISE to say, sorry, you've got to remediate, which means you've got to put some antivirus software on your laptop before I let you access the network. Or if you don't do it, I'll let you access the internet. You can get right back out to the internet, but you're not getting to our data center with our confidential data if you have a known virus potential issue or you don't have an antivirus software. So we can restrict any way you want. This makes it look like it's a single line, but in reality, there's many different lines of logic that comes off of this. Here's another example. What about anti-malware software? Malicious software comes in many different types here. Hackers, they only get smarter in creating harmful, evil, malicious software. It'd be nice to say we live in a world where people only wrote software to help us be kind, benevolent, caring, loving. I love the theory, but it's not reality. Bad guys are out there, and therefore there is all kinds of malicious software. So laptop connects in, and we have defined, you and I, that in this case here, that we want to say you need to have antivirus, anti-malware, and which products we choose is up to you and I. Maybe you like McAfee. Maybe you want to go to Malwarebytes. Maybe you use a product from Norton. Maybe use whatever. Cisco isn't deciding that. You and I decide that. And we decide if that's our standard, you got to have it on there. And then the user can say, okay, I'll put it on there. And then ISE will say, great, if you'd like to install it now, click here. Then ISE will redirect it to our server in our network that has our antivirus installation software that gets put on their device. Granted, it's going to take them a little longer to log in, but before they get anywhere on the network, we know they're going to be locked down and secure. So you and I define what this is. We can make it tremendously secure or very easy or anywhere in between. Cisco does not define that. ISE doesn't define it. You and I define it. If you say no you got to have antivirus. You got to have anti-malware software. You could even say with the posture requirement, you must not have this file on your C drive, literally. And it will look on their C drive, C:\/ whatever. I see this executable. Sorry, you don't fit it because we have a known security issue of that executable. Or you could say, look inside the registry of the Windows 10 desktop. And if you don't have this entry, or if you do have this entry, you don't require. And so what do we do after we get those requirements? You and I can program any logic we want. We can say, you don't have any access. Or we can say, you can get out to the internet. Or we can say, you can get to our public devices, order coffee at our kiosk, but you're not getting to our data center. Or we can say, if you meet all the requirements, we'll give you full access to the network. Again, there's no right and wrong to this, but whatever security objectives need to be met, ISE can do that. It's the beauty of programming is it's as creative as you want to be with the use of if then else logic. Okay, here's another scenario. What if I have a Windows 10 laptop and on side of it, I'm running a unique type of program. It sure was fun downloading it off the internet. It sure looked harmless. It got all these pretty little colors of the background. It's got some corrupt and malicious software built in. Well, as our security analysts identify that, we could easily make a posture requirement to say if those files or this program or that registry entry is in your laptop, then you've got to run anti-malware. And before you connect to the network, you still have to have that complete. Then I'll give you access. Okay, then you can say, well, boy, we're being awfully hard on our users here. We're making them do all these things. Okay, if you feel that way, then you're right. You could say, okay, we see you have no antivirus and no anti-malware. We'd like to suggest that you download the software. All you got to do is press here and wait 5 minutes, and we'll do it all for you, built in ISE, but we'll give you the option. And you say, wait a second, I got to get in the network and check my email right away. So if you and I want to be easier, and therefore less secure, we can make the requirement to say the policy is we recommend you to do this, but if you don't want to do it, okay, you're on the network. Later, we'll advise you again. Now, again, that makes it easier. We can decide that, certainly less secure. So again, Cisco is not an antivirus software company, but the posture requirement can work with it. Cisco doesn't make anti-malware, but we can work with it. Cisco doesn't create perhaps software to remove a keylogger. But if you got one, Cisco ISE can work with it. That's the cool thing about this. Okay, so again, this line here, please don't take that as literally. We can change it. It's not a line. It's not just linear. We could change it to any type of logic we want. Simple point. To be brutally honest, take a Windows 10 laptop, go surf around the internet. Take an iPhone, go surf around the internet. I say this very openly. Reality. Which one is likely going to get a greater chance of a virus? If you're clicking around on lots of stuff, Windows 10 is far more subjective to being prone for attacks on that device. It's just reality. Okay, that could be thought of as a benefit to Microsoft in that their software allows a lot of flexibility to what we could run in on it. But that same flexibility is the same attack vector that a virus would come in. So we might say, if Joe logs in on his iPhone, well, you don't got to do that much. We'll let you access our network. But if the same Joe picks up his Windows 10 laptop, we might say that condition is different. How do we know it's different? Because posturing works with profiling. Profiling is the ability to identify the device, the hardware that connects in, and after the user connects in, you and I define the condition we want to do to decide what we can let go from there. We could even say, if you don't have antivirus and anti-malware, and you're not willing to put it on right now, we'll make it easy for you. You just press this little button, so ISE says, on your laptop. But if you don't want to press it, I'm sorry, no network for you. We can do that. I'd be cautious with that. For example, in the healthcare field, it's common to have a scenario where a guest surgeon comes in a hospital and has their laptop and needs to get into surgery shortly. And with their laptop, they need to quickly access some key patient data relevant for surgery. They brought in their laptop. The guest doctor, did a bring your own device. All right, how much do you and I want to lock that down? Be cautious with that. Because if we insist on downloading software, that takes 20 minutes and they got to get to surgery in 10 minutes and they need a laptop for that, we could create a bigger problem. But again, that's the trade-off. Security isn't always easy. That's the reality. If everyone was good boys and girls in our world, this would be a lot easier because we wouldn't have to solve against them. But posturing is the solution to the fact that any type of malicious software, whatever could occur, is required. Here's another example. I've done some work for some top level uh, government law enforcement agencies. And when you walk in their main data centers, you're not bringing any USB drives. I mean, not even possible. Even if you don't have any access to anything else, you can't bring that in for point of copyright issues, security. So we could make a remediation that literally said your USB drive, it's got to be disabled on your device before you bring it in. You can't be allowing that to copy anything over. We could insist upon that and then literally make sure it's done before you actually access the network. Or once again, if you don't want to do it, okay, we'll let you get out to the internet. You're out of our network. You can go over there. We'll give you a nothing but net off to the internet. But again, if you want to access anything in our network, it won't happen. So this takes a lot of thinking and planning and organizing to allow for all the different scenarios. But if you have a scenario of someone accessing the network, posturing can take care of it there. All right, folks, great questions. And I intended to include as many of those inside the discussion. But at this point, let's open this up to any other questions you may have. Happy to take any questions.
Yeah, and if you have questions, type them into chat or Q&A. Chris, I did have a question or curious from your work in the field. Have you got any good advice for troubleshooting or something that you experienced that can save some of our attendees a lot of time? And I'm thinking when it gets a little bit in the weeds, like licensing or certificates, any issues or concerns with that?
Yeah, that's a good one. And one of the best ways, and a tool built into ISE here, is know everything that's going on. And ISE does a wonderful job of the monitoring and troubleshooting. This is an extremely detailed logging, not only real-time logging, but long-term logging. Example, a user says, hey, I'm trying to connect in, having troubles. So what we can do is, for every detail when they come in, we'll enable this persona or node. Just click the few buttons when we're installing ISE. Typically, this is made as 1 or 2 different servers, and give it a lot of extra hard drive space so we can do long-term logging. So we can do live logging and or long-term logging. How do you troubleshoot something best? More eyes on the game, higher visibility. The more you hide from me, the more I can't fix something. The more I can see everything, the easier it is to fix. Maybe the
Chris,
problem was the user had the caps lock on when they're typing the password. If we get real simple, we'll be able to see that right inside here. The
okay.
monitoring will share all that info for us.
Yep, and Chris, we got a few more Q&As that came in, and we got to watch our time to the top of the hour. You could address those.
Yep, Mike, can I deploy building per building or specific users? Yes to all the above. Very, very flexible like that for sure. So example, the key is the network access device needs IP connectivity to the policy service node. That's the key requirement. So if we have 10 buildings with 10 NADs, we might have just 1 or 2 policy service nodes that provide all of them. Caution, if there's only 1 PSN per campus, that's a single point of failure. So literally, if you can't get to the policy service node, radius isn't working. No radius, no login. If no login, well, we can't even get to the profile and posturing and all the other things, and the user's locked out. So enough fault tolerant of the PSN to ensure that the NADs can always reach 1 or more policy service node. That's the key thing there, Mike. As far as usernames, very flexible. In Active Directory or LDAP, you could set up users and groups. I could use a group in Active Directory to put that in a posture. So we could say, if you're in a group in Active Directory of all of our top tier 1 consultants, then we're going to make sure you have access to where you need to go. We know you have approved laptops you're in. So posturing could take that any way you want based on the different usernames. What are the resource requirements to manage ISE in a 10,000 device environment? Great question. Key point is, start with don't make just one server. Okay, so to do that, we want to spread things out. In reality, the numbers of the policy administration node, that's simple. It's either 1 or 2. Those are the options. The monitoring, it's either 1 or 2. PX grid, it could be between 0 and 1 or 2, depending how many you want. Okay, but Don, the key answer question is all about the policy service node. These guys are the ones you don't want to skimp on. So I would never consider only one policy service node. Again, depending on how your campus is laid out. Let's say, for example, you have 5 buildings, they're in the same geographic location, you have a good reliable connectivity between the two. On the low end, I might go with 2 PSNs, but do consider having an option of 3 or 4 there per location. Next, let's say I'm in San Francisco and Seattle. I would consider putting 2 through 4 in San Francisco, a different 2 through 4 in Seattle. Because what if we have any WAN connection that goes down? Goal, don't ever let radius go down. So the PSNs don't need a lot of hard drive space. So in terms of resource requirements, the only thing that needs hard drive space is the logging, the monitoring. Again, depending on how much you want to log and how much you want to maintain them for. The PSNs, they need CPU and RAM. Okay, so again, don't buy a 4 gigabyte server and run 2 PSNs on it for your 10,000 devices. That's way skimpy low. ISE loves a lot of good RAM here for sure. So I would go with probably 4 PSNs, 2 monitoring nodes, the 2 policy administration nodes, and again, up to you if you want to integrate with third-party products there. Give it sufficient RAM. Good news, when you install ISE in the open virtual machine appliance, and you give the number of users during the install, it will prompt you for the number of CPU and RAM requirements for that server. So at that point you say, oh, wait a second, I put this on ESXi and I only have 16 gigabytes of RAM, better be upgrading for sure. It's not going to run too good on that for sure. Okay, and it'll tell you that during the install as well. That's the benefit of an OVA.
And Chris, maybe have a look at some of the API features and functionalities to automate some of this.
Yep. Oh, for sure.
Yep.
And so anything you could do manually, any step manually, can all be done via REST. So if I can do any step manually, I could sit over here at Windows or Linux, write a Python script if you're good in that language, and then you could connect in with REST here as well.
Okay. Chris, we got enough time for one more quick answer at the top of the hour now. Quick question from Scott on ISE PIC. Or is that
Scott,
a question?
Can you clarify a little further on PIC?
I wonder if that's the pre-ASA device.
Just to make sure we're talking like with acronyms.
Okay. And Scott, if you can type in, if you can give us some more details on that. But Chris, let's move forward, moving along. We do have to close up. We are at the top of the hour. So what I want to do is thank you, Chris, and hope everybody enjoyed today's webinar. If you'd like to learn more about this topic, we recommend that you have a look at our CISE course. The Cisco ISE is one of our more popular courses where we offer it Global Knowledge. Best way to do that is to go to our website, globalknowledge.com, type in CISE, it'll get you to our landing page. Chris is one of our instructors that helps deliver this, and it's really good content. 5-day class has got 6 lecture-based modules, 21 hands-on labs. Okay. The other thing you might do is, if Chris did mention APIs, yeah, we do have the full DevNet suite. The Dev ASC is a good place to start, or Dev Core if you're looking at something like that. Next slide, Chris. And what we can do is, as an attendee today, we'd like to make it easier for you to take the next step. Use the discount code you see on the screen for 25% off when you book training with us. The US code is webinar 25. In Canada, it's CA Web 25. Next slide, Chris. And again, follow us on your favorite social media venues. There's the links for there. And I think that's it, Chris. We can go to the last one. One more. And we'll just close it up. I want to make sure that you continue to visit Global Knowledge website and have a look for the free resources, tech articles, white papers, webinars. I want to thank you very much. Chris, any last minute statement, and then we'll close this off.
Sure. One is, I see a note from Keith on the codes here. Keith, feel free to take a screenshot here. Realize we might have gone a little quick on that. And Keith, while you grab those codes here, Scott, thank you for putting the qualifier on there on the passive identity connector. So Scott, your key answer is all directions, Cisco ISE, top level security and clients, it's AnyConnect. AnyConnect is the direction, the focus of all client softwares on that. So Scott, there's how long can we hang on the past type of the question, how long in the future? AnyConnect is the present and future for sure.
Okay, and with that, I want to thank you very much, Chris, for your presentation. I want to thank all the attendees. Do go to our website and have a look at any future webinars that are coming out and any content and resources that we can help you out with. Again, thanks, Chris. Let's close this off, stop recording. Thank you all.
Great, thanks all. Thanks, Jerry Austin. You're very welcome, and pleasure working with you all here. Thanks for joining our webinar, and have a great day.